Hi everyone, this is Mrs. Snowbeck. Today we are going to do Unit 1, Lesson 4, and we're going to start by talking about rays. A ray is a part of a line with one endpoint that extends indefinitely in one direction. So will you do this for me? Will you take your pencil and draw a ray out through W? So if you do what I do here, you're going to start at X, and you're going to go out towards W, and you're going to put one arrow on. That is ray XW. And the way that you would write that is you would go XW and then put a bar above it with one arrow. And so it's really important when you name a ray that you put the starting point first. So in this case, X has to go first. That's where the ray starts, and then it goes off towards W. Let's do another one. So this time, let's start at S and draw a ray out through T. So there it is. And the way that I would name that ray is that would be ray ST. And again, I started it at S, and it went out toward T, and it will continue on in that direction forever. So S is the starting point. S has to go first. I want you to draw in a couple more rays. So the first ray that I want you to draw in is ray BA. Okay, if you did it correctly, it should look like this, starting at B, going out toward A. I also want you to draw in ray BC. And there's ray BC. These two rays formed an angle. And that angle we could name a couple of different ways, but I would either name it angle CBA or angle ABC. Imagine yourself tracing along the angle. So if you were tracing along here, you could start at C or you could start at A, but B would have to be in the middle. B is known as the vertex of the angle. It's like the corner or the point. And so B is the vertex, and the sides of this angle are rays. One of them is ray BA, one of them is ray BC. So we've named the angle, we've named the sides, and we've named the vertex. Remember, a vertex is like a corner of an angle. You can have points that are interior to an angle and exterior to an angle. Remember, rays go off forever, so even though they're not drawn, you can't draw them. It's humanly impossible to draw them forever. Imagine them going forever. In this case, point E would be in the interior of angle CBD, and point A would be on the exterior of angle CBD. Let's try a few. Number 1, name a point on the exterior of angle DEB. So I'm going to trace it. I'm going to go from D to E to B. So there's the angle we're working with. And it says name a point on the exterior of that. So imagine something outside of that angle. This is the inside. So we have to name something that's not in there, not on the inside. So G would work, F would work, and I think that's it. Number 2, name all the angles that have B as a vertex. So B is right here. We have to name a lot of angles. We have to name this one, and this one, and this one, and this one, and then there's even more beyond that. So one angle that I see is angle 5. I also see angle 6. I also see angle 7. But then that fourth angle that we marked does not have a number. So in that case, we have to use 3 letters. So we could call that angle GBA. GBA. Watch as I trace this. So from G to B to A, that's this angle over here. That's that last one that we named. There are a couple of more angles that you could name. For instance, imagine if you have a straight angle. This angle right over here, that also has a vertex at B. So you could also say angle GBD. GBD. That's a straight angle, but it is an angle with the vertex at B. You could also say angle ABE. And it goes on and on. There's a few more as well. Number 3, name the sides of angle 5. So angle 5 is right here, this angle over here. So one side you can see starts at B and goes out toward G. So that side we could call ray BG. Starts at B, goes out towards G. B has to be listed first. The other side of angle 5 starts at B and goes out towards E or F. So we could either name that line BE or line BF. Number 4, what's another name for angle 6? So angle 6 is this angle right here. Another way to name that angle, if you just think about tracing along, I could start here, I could go here, and I could go here. That would also be that same angle, angle 6. So that would be called angle EBD. Or you could reverse that and go angle DBE. Please take a minute and pause the video and see if you can remember what these angle types are called. You learned names for these, and if you know anything about their measure, also fill that in. When you're done, then go ahead and unpause the video. The first one is a right angle. A right angle is exactly 90 degrees. I know it's a right angle because it has that little red box in the corner. The second one is an acute angle. I like to say it's a cute little angle. It's this angle right in here. Acute angles are basically between 0 and 90, or if you want to say less than 90 degrees. The next one, that is an obtuse angle. Now an obtuse angle, like this one, has to be between 90 and 180, or in other words, more or greater than 90 degrees. And then finally, last but not least, we mentioned this a minute ago, this would actually be called a straight angle. It's wide open, it's flat, it's a straight angle, and its measure is 180 degrees exactly. Please take a minute and try numbers 5, 6, and 7. Circle if you think it's acute, right, or obtuse. When you're done, go ahead and check your answers. So angle SYT is right in here. That looks to me like it is less than 90 degrees. Angle SYX, if I just erase this one, SYX, if I trace it, SYX is this angle down here. That looks like it's greater than 90 degrees, so obtuse. And then the last one is VYX. And VYX, if I trace that, goes like this. And notice that box inside of there. That is exactly 90 degrees, or a right angle. I know in science class you've had to dissect things, which means you take it all apart into many different parts. But in math, sometimes you have to bisect things. A bicycle has 2 wheels. When you bisect something, you cut it into 2 parts. But not only 2 parts, but 2 equal parts or 2 congruent parts. So an angle bisector is a ray that splits an angle into 2 congruent angles. Now notice in here we have 2 little red curves. That means that those angles are congruent to each other. If I would have had something like this, where I have maybe 1 curve here and 2 curves here, those angles are not congruent to each other, and that ray in the middle would not be an angle bisector. So a bisector cuts it perfectly in half. There's a couple things that I want you to write down here. I want you to write down that ray XY is the angle bisector. And then I also want you to write that angle WXY, which is the one kind of on the left, would be congruent to angle YXZ. They end up being equal to each other or congruent to each other. Some of your homework will be like this. Let's try number 8. Ray KN bisects angle JKL. All right, let's look at the picture. Find angle JKL. I'm going to kind of outline it here, JKL. Now that gets bisected by ray KN. So start at K, go out through N. Aha, this part and this part must be congruent. Go ahead and put those little curves in there. All right, now let's mark what we know. The first thing it tells us is that the measure, this means measure, so the measure of angle JKN is 8x minus 13. Well, JKN is this angle down here, 8x minus 13. I'm going to write that in there. And angle NKL is 6x plus 11. That's this angle up here. Find the measure of angle JKN. Well, I think before we can find the measure of angle JKN, we need to know what x is. So we need to set up an equation. And the thing I know about these two angles is that they're congruent to each other. And so the 8x minus 13 equals the 6x plus 11. They're the same size. Use your algebra, solve it for x. And I get x equals 12. Now we're not done though. It says find the measure of angle JKN. Well, angle JKN, if I kind of outline it here, remember that's down here in the blue. And so I need to take that 12 and I need to plug it in to that angle. So the measure of angle JKN is going to be 8, but instead of the x, we're going to plug in a 12 minus 13. And 8 times 12 minus 13 is 83 degrees. Last but not least, I believe this one is actually number 9. It says, given ray QS bisects angle PQT. Let's just stop there. Will you take a minute, pause your video, try to draw just this part, this top line. Try to draw that. Go ahead and pause. Okay, there's my angle PQT, and ray QS has to bisect it. So maybe something like this. So that this angle here and this angle here are the same size. Now, it says the measure of angle PQT is 6x plus 4. Well, PQT is actually the whole big angle. It's this whole thing is 6x plus 4. And TQS, which is this bottom part, is 7x minus 2. And they want us to find the measure of angle PQT, the big one, the huge one, this part. Well, they're not equal to each other. One of them is big and one of them is small. They're not congruent to each other, so we can't just say that they're equal. But I do know that these two angles are equal. So if angle TQS is 7x minus 2, I can also say angle PQS is 7x minus 2. They have to be the same size. So in other words, the two small ones added together should equal the big one. Or 2 of the 7x minus 2's together should equal the big one, which is 6x plus 4. Many ways to do this. Probably the quickest way is to distribute. So you wind up with 14x minus 4. And then you just do your algebra. Add your 4. And I believe if you divide by 8, x equals 1, which is great, but it's not our final answer. We need to find the measure of angle PQT. So remember, angle PQT is the big one. So I'm going to take that 1 and I'm going to plug it in right there. So the measure of angle PQT equals 6 times 1 plus 4, which is 10 degrees. Is my picture drawn to scale? No, not really, but that's okay. It doesn't matter. It helped me set up my equation and get it right, so it doesn't need to be drawn to scale. That wraps it up for 1.4. Please try Unit 1, Practice 4. Drop it to me in Schoology when you're done. Thank you. Have a good night.